This is going to be using the Pythagorean theorem to find the distance between 2 points on a coordinate system. And we're going to explain how that works here in just a minute. But first, let's recall and remember what is the Pythagorean theorem equation. So we come up here and we remember that it's just, we got to get a marker. And it's just a squared plus b squared equals c squared. And remember that a and b are just the two short sides of the triangle, of a right triangle, and c is the longest side of a triangle. So if I look at this, I happen to notice that I've got a and c, but I don't know what b is. So if we write this out, a would be 12. So 12 squared plus b squared equals c squared. And c squared happens to be 13. So I didn't want to put a c there. I want to put 13 squared there. So it's 13 squared. Now let's multiply this out. Now we do know what 12 squared is. That's just 144 plus b squared equals, and 13 times 13, not everybody knows what that equals. So let's get our calculator out. 13 times 13, which is how you square 13. That equals 169. Okay, so let's get rid of that and bring back our pen. So we got 169. Now to get b by itself, we have to move the 144 to the other side of the equation. So we end up with b squared equals 169 minus 144. And 169 minus 144, well, if we're not sure, we get our calculator back out. There's 169, subtract 144, and that equals 25. So b squared, in our case, equals 25. And then to find out what b is, we just take the square root of each side of our equation. And on the left side, that b squared just becomes b, just like we did when we were simplifying radicals. And then the square root of 25 is 5. So the distance on b here is 5 meters. And that would be our solution. All right, thank you for that problem. Now let's move on. So what we're going to talk about is, what if we have a straight line on a coordinate system and we want to know how long it is? Well, on this first picture, it's really easy to tell that that thing just runs straight up and down one of these lines, and we can just kind of count. It goes from here, it goes 1, 2, 3, 4. So length in this case is just an easy 4, right? But what about this one? We got kind of a diagonal shape. So if you use your imagination, you can kind of construct a little right triangle here. We've got the base, or A, whatever one you want to call it, and this side. And we can count those sides on the coordinate system, so we know that this bottom side right here is 2. What about this side? Well, this side is 1, 2, 3 long. So 3 long right there. And then the side that we're going to be looking for will be C, because here's our right angle, and the C is on the opposite side of the triangle from the right angle. So when we write this out, we're just going to use the Pythagorean theorem. So we'll go a squared, and we'll just call this side right here a squared. So 3 squared plus b squared, which is 2 squared, equals c squared. Okay, now let's go ahead and calculate these out and see what we come up with. So 3 times 3 is 9. 2 times 2 is 4. And what's 9 plus 4? 9, 10, 11, 12, 13. So we got 13 equals c squared. And so we need to find out what c is. So we have to take the square root of c squared, the square root of 13. That's a 13. Square root of c squared is just c. And then the square root of 13, depending on what the problem's asking. So we look and we got to find the square root. So we go 13 square root. That's going to be about 3.6. So let's get that back out of the way. And that's going to be about 3.6, we said, if we round it to the nearest tenth. So there you go. There's your distance, approximate distance in this case. All right, so let's keep moving. Let's try a couple more of those. Those won't look too bad. So there's one that, oh my goodness, this looks very similar to the one we just did. So we've got a bottom here of 2 and a left side of 3. So a squared plus b squared. So I don't care which one you call which, but let's go ahead and kind of do it in the same way we did last time. So 3 squared plus 2 squared equals c over here. So c squared. Or 9 plus 4. Man, that's just about the same. That's the same problem we just did, isn't it? So when we take 9 plus 4, we get 13 equals c squared. And when we take the square root of both sides, once again, we get c equals, and from our last problem, what did we have? 3.6. Square root of 13 is 3.6. All right, let's see if we can get a different problem on here. That was kind of like showing you the same one, only it's oriented differently, but it turned out to be the same dimensions. Okay, what about this one? This one does look a little different. So when we do this one, I'm going to make a right triangle out of this, and I kind of like to go like this with them. There's my bottom, here's my side, and my right angle down there in the corner. And so we're going to have A and B. So how long is A? 1, 2, 3, 4. And then how long is B? Well, that's pretty easy. That's just 1 down there. So now we're going to try and find this diagonal. How long is C? Oops. So C is over here. Kind of stuck in. There we go. I was stuck in eraser mode there for a moment. All right, so A squared, so 4 squared plus B squared equals C squared. 4 times 4 is 16. 1 times 1 is 1, and that equals C squared. 16 plus 1 is 17. That equals C squared. And when we take the square root of each side, we end up with C equals, and if we do the square root of 17, we could just leave it as the square root of 17. That probably wouldn't hurt anything. But if we go ahead and find out what actually is 17 square root, that would be about 4.12, something like that. So 4.12 if we rounded it to the nearest hundredth in this case. So there's how you would find that distance right there. So we're just basically using the Pythagorean theorem over and over again. Okay, 1 or 2 more, and I think we'll be ready to go. So let's take a look. Our A, which is what we've been calling this distance up the side. So if we count that out, we get 1, 2, 3, 4, 5, 6. So that length is 6. Then we have B along the bottom. That's 2. And then C over here on our diagonal on the opposite side from the right angle. So let's go ahead and write that out. A squared plus b squared equals c squared. Okay, so 6 times 6 is 36, and we're going to add that to 2 squared, which is 2 times 2, or 4, and all of that's going to equal c squared. 36 plus 4 is 40, and all of that equals c squared. So to find c, we need to take the square root of each side, and we get c equals, and in our square roots, we go 40 square roots, and that's going to be 6.32 if we round to the nearest hundredths. So 6.32 if we round to the nearest hundredth. And that's not a bad number. We know it's going to be the longest side, and it's just a little bit longer than this side. We know it's not too much longer because our bottom down here is not very big. All right, so what do you think? Those don't look too bad. So when you get on to Alex, which is what we're going to be doing this assignment on, it might look something like this. So it says find the distance between points A and B, and it says each box is 1 unit long. So all you have to do then is just say, okay, let's create a right triangle by going over 1, 2, 3 units. And then we have this side, that would be how many units? 1, 2, 3, 4, 5 units. Okay, so now you're just going to do a squared plus b squared equals c squared. And you're going to get really good at this. 5 times 5 is 25. 3 times 3 is 9. All of that equals c squared. 25 plus 9 is 29, 30, 31, 32, 33, 34. So that's 34. And then if we take the square root of both sides, we can find out what it is. So we get c equals, and we do the square root of 34. So 34 square root, 5.83. Let's call it 5.83 because we rounded to the nearest hundredth in this case. And whatever problem we're doing, we'll give you the units we want you to round it to if it needs to be rounded. Okay, what about on a problem like this? They actually give you a couple of points, and it might be a little hard to just kind of count your way over and read them. So what you can say is, well, from this point, I got to go over from -3 over to +2. So it'll go from -3 to +2. That distance in the x direction is 5. And then in the other direction, we're going from -2 up to 1. So if I go from -2 up to 1, or from 1 to -2, I'm actually changing by an amount of -3. I'm going down 3. Well, that's interesting. How are we going to take that into account? So let's look at our formula. A squared plus b squared equals c squared. So we know that this distance along the bottom here, this distance along here is 5. This distance along here is 3. Now we've called it -3 because we're going down. Excuse me, so it's going down. So let's take a look at how that works. So a squared is -3 squared, and then b squared is 5 squared. And all of that's going to equal c squared. What's -3 times -3? That's 9. What's 5 times 5? 25. And so all of that equals c squared. And so 25 plus 9, 29, 30. So that equals 34. So when we take the square root of both sides, we end up with c equals I could have sworn we saw that 34 earlier. There it is. And that turned out to be 6.32. So in this case, it's 6. Oops, jumping around a little bit. Too much. 6.32 is the number we're looking for. So we did the same one over again, just like we did earlier. All right, so there's our last example. Let's make sure we got this down. So we're going to kind of use that same process that we did just a minute ago to go from this L, which is at -8, over to this E. We're going over how many places? Well, to go from -8 to -1, that is a change of 7. So this length right here is 7. Now on this one, we can go from this one up to this point if we want to do it in this direction. To go from 2 up to 7, that's a distance of 5. So now all we have to do is find the diagonal, which is C. And now we can use our formula. A squared plus B squared equals C squared. A squared is 25. B squared is 49. And all of that gives us C squared. So 49 plus 25. Grab our calculator. 49 plus 25 equals 74. So we're going to have a distance of 74 equals C squared. And then we have to do a square root of both sides. And when we do that, we end up with C equals, and grab our calculator one last time, 74. And then we take the square root, we end up with 8.6. So our approximate distance there is 8.6. So C equals 8.6, whatever units of measure it happens to be. All right, I think you can do it. It's Alex's assignment is called Finding Distance with the Pythagorean Theorem. Thank you very much.